pasal soalan tutorial 2. Okay, soalan tutorial question 2 ni, kalau kamu perasan lah soalan ni, dia adalah satu soalan, okay lah kot, clear, suara jelas, semua okay lah?
Jelas.
Okay, Alhamdulillah. Okay, kalau kamu tengok ni question number 2 ni, figure 1 shows a single line diagram of 3 phase. Okay, Sudin. So, kita tengok ni, kita ada question 2 ni. Alright, kalau kita dapat question ni, figure 1 shows a single line diagram of a 3-phase 60 Hz synchronous generator connected through a transformer and parallel transmission line to an infinite bus. All reactants are given in per unit on a common system base. If the infinite bus receive 1 per unit real power at 0.95 power factor lagging, you have to determine the internal voltage of the generator E prime. Okay, since E prime is not given, remember that you need the E prime, which is the internal voltage of the generator, for the power angle equation. Okay, you should substitute E prime value into this transient power angle equation. E prime multiplied with infinity bus divided by the total transfer reactance. So that's why you have to calculate what is the E prime. And secondly, the equation for the electrical power delivered by generator versus its power angle for pre-fault, during fault and post-fault if the fault occur at bus 3. Okay, student, normally during the exam, instead of saying this, I would like to ask you, or I would like to rephrase the question as evaluate the power system stability. Okay, so what do I expect if I ask you to evaluate the power system stability of the system? Okay, so I expect you to finally draw this power angle curve. Okay, I want you to draw the power angle curve. Okay. Okay, so when you got this kind of question, first, what you should do is every time you got power system stability study question, you have to draw the equivalent circuit. So for this circuit, okay, that has been provided in the question, you have to redraw. Okay, you have to copy and redraw the equivalent circuit. So you know that the transient axis reactance is XD prime 0.3, the transform is 0.1, and then you have between bus 1 to bus 2 J0.2, and then between bus 1 and bus 3 you have 0.1, between bus 3 to bus 2 is 0.2. Okay, and this question, okay, has mentioned that the fault occur at bus 3. Okay, the fault occur as bus 3. So you know that there is two types of fault. Okay, there are two types of fault, which is the first fault at sending end. Okay, the first fault is at sending end, and the other fault is some distance away from the sending end. Okay, So I would like to remind you again and again and again. Okay, if the question asks you for this kind of problem from the generator, and then normally it's through a double parallel transmission line to the infinity bus. Again, I would like to remind you what is infinity bus, student? What is infinite bus, student? What is infinite bus, student? Do you still remember what is infinite bus? What is infinite bus? Okay. What is infinite bus, student?
Large load.
What is infinite bus? I have told you so many times that the infinite bus is the large, okay? Is the large loads. Okay, I hope that you can understand what is the infinite bus. Okay, because if you don't understand what is the infinite bus, okay, you are not understand what we have discussed all this while, that the infinite bus is, okay, consider a generator here connected to a major substation of a very large system through a transmission line. So this, okay, I have mentioned so many times today that the infinite bus is the major substation, very large system through a transmission line. So infinite bus is a very large system. It may be, uh, okay, infinite bus, infinity bus is just the same. Okay, is actually very large system. Okay, consists of a major substation with has many loads connected to it. Okay, so we can consider that if we are connected to Kedah, so it consists of distribution system of Kedah or Perlis or even Kuala Lumpur, or even maybe Peninsula Malaysia. So we simplify all these large system with only infinity bus. Okay, I hope that you can understand what is infinity bus. Okay, so in order to simplify our circuit, we just refer the large system as the infinity bus. Okay, I hope that you can understand. I have repeat this again and again. I don't want you to confuse what is infinity bus. You have calculated it so many times, and again you don't understand what is infinity bus. So infinity bus is a very large system, okay, consists of a distribution system. So we simplify the large distribution system with only infinity bus. Okay, even though that I have repeat this again and again, I hope that you know that it's this is very serious, that if you don't understand what is infinity bus, you are going to have difficulty in answering the final exam question. Okay, I hope that you understand, okay, on this. And so student, again, so now for this question, I ask you to calculate first what is the internal voltage of the generator. So you have to draw first the equivalent circuit. So from here, J0.3, the transient axis reactance, and then you have transformer, which is J0.1. Okay, I hope that you now can understand what is B11. So what if for this case, I would like to ask you, what if I open B13 and B22 during fault? You know that during the fault, I will open the circuit and it become like this. Okay, this is during post fault. Okay, the circuit breaker will open during the fault. Okay, so that's why we can calculate we can draw the power angle curve, and then we can calculate what is the power angle equation for each condition. Alright, so what is power factor? 0.95. It is given in the question, okay? Okay. So all reactors are given in per unit, okay, here. And if the infinite bus receive 1 per unit real power, okay, which is the PE is equivalent to 1 per unit, okay, and then the power factor is 0.95. Okay, and then the power factor is 0.95. Alright, so you know that from this equation, first you have to redraw. You know the fault occur as bus 3, okay, as mentioned in the question, fault occur at bus 3 here. And then you know that for before pre-fault condition, so you know that the power from the generator can be supplied to the infinite bus, okay, through the parallel transmission line. Okay, so first what you should do, student, so you should get what is the since you don't know what is the E prime, so that's why you have to calculate the E prime first. So for this case, okay, the angle, okay, since the power factor is 0.95, the angle is 18.20 degree. And then what is your apparent power? Okay, which is S, P divided by power factor. And then how do I know that my electrical power is 1? It is given here in the question. The infinite bus receive 1 per unit real power. Okay, so 1 divided by 0.95, the power factor, you're going to get 1.0526, angle 18.20 degree per unit. And then the current is S conjugate divided by V bus conjugate. What is V bus? Okay, V bus is actually infinity bus. Okay, student. So the infinity bus, it is given in the question. Okay, so normally I would like to write as V infinite equals to 1 per unit is very similar to V bus. V bus, which is the infinity bus of voltage. It's just the how I want to write down the voltage. It is just the same, the infinity bus voltage. Okay, I hope that you can understand. So the S conjugate, which is this value, will be divided by V bus, which is 1. That's why you are going to get minus here because of the conjugate. That's why from positive is become negative in order to get the current. Okay, once I get the current, okay, so you know this, all these XD prime plus X transformer reactance plus this parallel transmission line reactance can be simplified as total transfer reactance, okay, which is XT. Okay, so how to calculate that one? You know that this transient axis reactance and transformer reactance is in series, plus this, and it also in series with the parallel reactance of these transmission lines. So you can calculate and get the J0.52, the transfer reactance. Okay, how do I get my E prime here, student? How do I get my E prime? You know that the voltage, okay, voltage across the transfer reactance plus the voltage across V infinity bus, you are going to get the total transient internal voltage, the generator internal voltage of the generator. Okay, so voltage across XT plus V bus, that's your internal generator voltage. So V bus is 1, okay, as given in the question, plus JXT. And I want you to remember, student, even though that for all this while I've been used 1 as the infinity bus, actually it can be anything for the V bus, not necessarily 1. Okay, I hope that you can understand. So 1 plus JXT times I. So your XT you have calculate here, your current you have calculate from this calculation here. And then from here you are going to get what is your voltage behind transient reactance or generator internal voltage. Okay, you know, okay, for this question, the equation for the power angle delivered versus power angle, so you have to write down, you have to determine the power angle equation for three different condition. Okay, you know that I have teach you for this that when it's some distance away from the sending end, you know that the fault should be okay. So you know that the fault maybe somewhere around at the middle or some distance away from the sending end, not necessary at the middle of the transmission line. Okay, and if its sending end is very near to the sending end voltage Vs, but if it's some distance away from the sending end, you know that you have to draw three types of power angle curve, which is power versus rotor angle. So you know that pre-fault, okay, which is the highest power that you can transmit to the infinity bus, and then you know that during fault you are going to have the lowest power transmit to the infinity bus, and you have post fault condition, which is your power has been increased, but since that you have only one transmission line, so that's why you have restrict the power submitted transmit to the load. Okay, so what will happen to the when it is the fault occur at the sending end, student? What will happen if the fault occur at the sending end? You know that during fault, okay, during fault, PE will be equals to 0 and P1, okay, pre-fault will be equals to P2 because the fault are not damaging, okay, your transmission line are intact and not damaging your transmission line. That's why you are going to have only one curve for your power angle curve, which is P1 will be equals to okay, I want to use P1 as pre-fault, okay, P2 as during fault, and P3 as post-fault. Okay, so P1 will be equals to P3 and your P2 will be equals to 0, okay, during fault. So I hope that you can understand what is the difference between for sending end and for some distance away from sending end. Okay, so you know that for this case, since the fault occur at some distance away from the sending end, which you know that you are going to have these three types of power angle curve, okay, for three different conditions. Now you have to calculate what is the pre-fault. Okay, so E prime times the infinity bus voltage magnitude. So your E prime, which is 1.2812, multiply with infinity bus given in the question, which is 1, divided by the transfer reactance J0.52 sin delta, you're going to get what is the power angle equation. And during fault, again, I have discussed with you so many times, student, okay, you have to convert this to delta so that you can finally calculate, you can finally determine what is the transfer reactance between the E prime and the infinity bus. So, okay, so you have to find out what is your XT here, student, which is from star delta transformation. I think that I have discussed this so many times. In order to find what is your XT, J0.4 times J0.2 plus J0.2 times J0.1 plus J0.1 times J0.4 divide by the opposite reactance. So you're going to find this transfer reactance here. So you have to divide by the opposite reactance, which is J0.1. That's why you are going to get your transfer reactance J1.4. J1.4. So what will happen to your X1 and X2? You are not going to use it because the only reactance that you need for your calculation here is the transfer reactance between E prime and infinity bus. Okay. So you just substitute into this equation, which is your XT, the new XT during fault is 1.4. You are going to get 0.9151 sin delta. And then post fault. What is post fault? How to calculate for post fault? You know that when the fault occur, okay, anywhere around this transmission line, you know you have to isolate. You know that you have to isolate. your fault here. So your circuit breaker, which is B13 and B22, will open. And what will happen to your circuit? Your circuit will have only one transmission line to the infinity bus, which is from bus 1 to bus 2. So this line will be isolated. This line will be isolated. That's why for post-fault condition, you can redraw the circuit as J0.3, which is your XD prime. Okay. And this is your transformer reactance, which is J0.1. And then you are going to have only the other transmission line, which is J0.2. So the total transfer reactance is J0.6, which is XD prime plus transformer reactance plus the transmission line between bus 1 to bus 2, J0.2. That's why you are going to get the new transfer reactance J0.06 during fault. Student, do you understand how to find all these reactance? Is very important, and it's very easy actually, but you need to understand. Okay, you need to understand. The step is there. Okay, we have discussed this so many times. I hope that you can do it correctly in your final exam. Okay, so E prime times infinity bus divided by the transfer reactance and delta. So E prime will be 1.2812, which is you have calculate from here your generated internal voltage 1.2812, which is your E prime. Just take the magnitude times with the infinity bus divided by the transfer reactance. Okay, 0.6. The power angle curve for all condition is, so you have to draw. Okay, you have to draw the power angle curve. So when I ask you to evaluate, I expect you to draw the power angle curve for all the condition. Alright. So up to this point, again, you have to from P naught, which is the pre-fault. Okay, P naught. Okay, since okay, so if student, there are some condition that okay, there are also some condition if I use P naught, so this will be my P naught, this is my P1, this is my P2. So it's okay whether you are using P naught, P1 or P2, but remember that please use the same nomination, the same name for the whole the whole calculation. Don't use differently for different question, so I may get confused and give you wrong marks because I assume that you get wrong answer. So make sure that you write down P naught is for steady state, P1 is for during fault, P2 is for post fault. So it is clearly explained which symbol that you use for different condition. Is it okay, student? Faham tak? Student, okay tak? Okay, faham Right, good. Okay, so your P naught, which is steady state, is 2.4638. And then this is the pre-fault condition, and during fault you are going to get 0.9151 sin delta, which is this is the maximum power, and this is your power angle curve. And then post fault you are going to get 2.1353, okay, which is this. Okay, I hope that you can understand from here what is your how to draw. So what is your electrical power here, student? PM? Your PM should be 1. Your PM should be 1. So you can draw your PM. Here, your PM will be here. Okay? This is your PM, which is equals to 1 per unit. Okay? Okay. So I hope that you can understand what is your how to calculate that one. And then I have discussed with you so many time on question 8. Okay, I've discussed with you so many time about question 8. Okay, so again the same thing for okay never mind, I will go back to question 8 later. Okay. For question 2 student, for question 2, okay, what happen if the same question, single line diagram, 3-phase 60 Hz generator connected through a transformer, okay, through a transformer, connected to a transformer through parallel transmission line. Connected to a transformer through a parallel transmission line, parameters are given. If the infinity bus require lower demand of electricity by 62% of 1.6 per unit real power at 0.95 lagging power factor with 1 per unit voltage magnitude through a parallel transmission line. Okay, the same question, if I rewrite, okay, instead of giving the information in the picture, I also can rewrite like this. Okay, so you know that from this question, what is your PM or PE? Okay, what is your PM or PE? So your PM or the PE is equal, which is the electrical power equals to the mechanical power. So the infinity bus require only 62.5% only. Okay, so what is the electrical power that is needed by the infinity bus? So you know that the real power is 1.6, but your infinity bus requires only 62.5 only. So to calculate the electrical power is 0.625 times 1.6 per unit. You're going to get 1 per unit as well for your electrical power. So it depends on the calculation, but I hope that you can understand how to calculate it's not necessarily your infinity bus should be 1, your real power should be 1. So it can be anything, but you have to understand. That's the important question. That's the important point that I want to discuss here. And your power factor is 0.95, your infinity is 1. So I hope that you, even though that it is right down, is actually the thing that you have known already. So please read again and again. The question is not very difficult when you have some information are given in the question. So you just need to understand. Okay, and make sure that you can extract the information from the question. That's the important thing that I want to discuss with you. So again the same thing as the previous question. XD prime 0.3, transformer reactance is 0.1, and then between bus 1 to bus 4 the reactance is J0.3. Okay, and then between bus 1 to bus 4 you have 2 different bus, okay, connecting all these transmission lines, okay, which is bus 1 to bus 2, bus 2 to bus 3, bus 3 and bus 4. But unfortunately, you have fault at bus 2. Okay, so what will happen if you have fault at bus 2? So it's very simple, student. Again, you have done this so many times, so no need to worry. The fault can happen anywhere, but you can still calculate. Okay, what is the transfer reactance? Draw the equivalent circuit. So your generator is here. And again, this question, okay, doesn't give you what is, this question don't give you what is the internal generator voltage. You know that you have to calculate the generator internal voltage because even though it is not given in the question. because finally you are going to use E prime in your formula for power angle equation. Okay, so at this point, you know that how to calculate the E prime. Okay, you know that you have xt, you can calculate the xt, and then you know that from the question, the infinity bus is given, which is 1 per unit. Okay, so voltage drop across the transfer reactance plus the voltage at the infinity bus. Okay, you are going to get what is your generator internal voltage, E prime. Again, the same thing, student. First, redraw. Lukis balik. Redraw the equivalent circuit, which is 0.3, 0.1. Okay, the transmission line reactance is 124, 0.3. Okay, and again 0.1, 0.2. And every time you got any question, please check what type of fault. Okay, what are the type of fault? Okay, what is the type of fault that the question asks you? So you know that for this question, it is the fault occurred some distance away from the sending end. So finally, you know that you have to draw this kind of power angle curve. Alright. So again, the same thing. Theta, which is the power factor, 0.95. You are going to get what is the angle, 18.20. What is the parent power? The power divided by power factor. How do you get your power? Your power is obtained from here. Student, you know that 62.5 of 1.6. So the electrical power that is being supplied to the infinity bar is only 1 per unit. Okay, that's why from here 1 divided by 0.95, which is the power factor. It's also given in the equation, 0.95. And don't forget that the angle is 18.20. The current is S conjugate divided by infinity bus 1.0526. The angle is minus. This is positive to negative. Okay, I hope that you can understand that it's not very difficult. It's easy. You have done this so many times. Okay, in your tutorial. Voltage behind transient reactance E prime. Again, you can calculate this. Okay, since XD prime plus transform reactance is J0.3 plus J0.1, and you know J0.3 is parallel with this reactance. Okay, sometimes it's not symmetrical. Okay, sometimes it's different, but it's okay. The same thing. You can calculate what is the transfer reactance. Finally, we're going to get J0.55. So E prime should be V bus plus voltage across the transfer reactance. You're going to get the same answer as question 2. Okay. I hope that you can understand this, student. What is your pre-fault? Okay. Again, you can use this for your pre-fault calculation and during fault calculation and post-fault condition. Okay. So you are going to get what is the power angle curve for all condition. Okay. Do you have any question here, student? Do you understand? Faham tak? Alhamdulillah. So banyak. So I hope that you please. I really want you because sometimes is definitely the question. Sometimes I need to increase the level of the question lah. Okay. I have to say this that, but please don't fear. Okay. The question, you know that you have done the question so many times, you have done so many revision, you have done so many tutorials, you have done so many exercises. So don't worry. Okay, what type of the question that will come out? You must remember that this question I have tried it so many times. I have done this question so many times. You just need to read carefully and extract the information from the question. That's the most important thing. Okay. And then I would like to discuss again question 8. I hope that you can remember this one, student. Again, equal error criterion. For ascending end, you know that you have to draw only one power angle curve, because during fault the electrical power or PM will be equal to 0, and if it is some distance away, it may be not necessary at the middle of the transmission line. It may happen at any location of the transmission line. It may be occur at 1/3, 1/5. I have discussed so many times with you. I hope that you can understand. It's just very similar. Just calculate the total transfer reactance. Okay. So for this case, here student, okay, it is given the H initial constant, SD prime is given, and then this is the real power PM, which is 1. Protection, the fault clears. You know that if there is a circuit breaker here, when the fault occur here, so this circuit breaker will be used to isolate the fault. Okay, so this will be open during post fault condition. And clearing time 75%, analyze the initial system, propose the solution, and assume the power of the PM is 0.8. So please check, okay, student, if I ask you to evaluate, okay, remember student, at any point, at any question, I will ask you to evaluate what the power system stability. I would expect you to draw this power angle curve. This is how you evaluate the power system stability. Okay. So student, for this case, you know that the fault occurred at the middle of the transmission line. So the pre-fault condition, find the ST. Then you are going to get what is the power swing equation, power angle equation during the fault. You know when the fault is occur here, you have to do the star delta transformation to get the XT prime. And then after fault, the fault location will be open due to the circuit breaker. Okay, and the fault will be isolated, and you have only one transmission line to supply power from the generator to the infinity bus. And then you have the power angle curve, which is here. Okay. If I ask you what is the critical carrying angle and the critical carrying time, you know that you have to use this formula here. Okay, student. So for this case, once you get this power angle curve, okay, write down what is the PM. PM is your electrical power, is always given in the question, power in per unit. And then write down is P0, P1 and P2, and what is your PM. And use the critical carrying angle to find what is your critical clearing angle and delta naught and delta max. Okay, by using the formula, please make sure that your calculator is in degree to get the correct answer in radian. Okay, by using the equal error criterion, I don't expect you to derive this, but it's good for you. Okay, and then by using the formula, you can calculate what is the critical clearing angle. And then if I ask you to reduce by 75% from the existing, the original critical clearing time, you should reduce it by 75 by 1 minus 75%, which is 1 minus 0.75, which is 0.3775 second. And then once you got the TCR new, you can rearrange the formula here to get what is the formula for your TCR new. And then finally, you are going to get the new critical clearing angle. Okay, what will happen if I ask you to reduce, student? Okay, I want you to reduce. Okay, the question asks you to reduce by 3 cycle from the original TCR. So again, it's also very simple. Your frequency, if it's not given, by default the frequency is 50 hertz. So you know that your time, per cycle is 1 divided by 50 hertz, which is 1 divided by 50 hertz, you are going to get 0.02 second per cycle. So you are going to get 0.02 second per cycle. So for this case, student, for example, to reduce by 3 cycle. So 3 cycle will be 0.02 second times 3 cycle, 0.06 second. 0.06 second. So which is from here, your TCR new should be 0.1502 second minus 0.06 second. This is your TCR new. I hope that you can, and then once you get this value, you can substitute into this equation here to find what is your critical clearing angle new. I hope that you can understand how to do it for this one. And you have, again, question I asked you so many times. We have discussed this so many times. And if I ask you, supposedly you should answer this one correctly. No need to worry or anything. And again, I want to ask you what is the critical clearing angle and what is the critical clearing time. It is actually the longest fault duration before your system become unstable. So you should make sure that at any fault you have to remove the fault before this critical clearing time. Before the critical clearing time, because it may your system will lose its stability and it may damage your generator, and and it will lose its stability. It may cause blackout, loss of power supply to the load. Is there anything? And one more, if I ask you about the fault at sending end, you know that you have to draw one only power angle curve. So for example, this for example, this kind of question, student, what happen if I have a fault at sending end here? What happen if I have fault at sending end here? Student, for this kind of question, if I have fault at sending end, so what is my XT? What is my XT, student? My XT should be during, you know that during fault, P0 will be equals to P2, right? So my XT should be the same thing as here, J0.52, because since there is no fault here before fault and after fault. So I can straight away use the XT equals to J0.52. And then how to draw my power angle curve? P0, which is equals to P2. Again, I can use the similar equation here for pre-fault. Okay? Alright. So this is the answer if I ask you the fault occur at sending end. And you should draw the power and rotor angle here, which is the maximum power is at 2.4638. Okay, and then for this case the power is at 1 per unit, so you just write down that this is your PE, which is occur at 1 per unit. Okay, so it's very simple and easy question to answer. I hope that you can get the highest mark for this type of question. Okay, student, for power system stability study, is it okay now? Or do you have any question to ask me?
Doctor,
Yes.
Doctor, is it today we discussing is about the question 2 for our stability in final exam?
Please don't ask me what will be covered in the final exam question. I have told you so many times. Okay? Definitely, you know what is the objective of I'm having this kind of revision class. Definitely revision for final exam. Correct?
Oh, okay. Thank you, Doctor.
Okay?
Okay. Thank you,
Don't
Doctor.
ask me what we cover in the final exam question. This is revision class. You should understand it by yourself.
Okay. Okay.
Okay. Clement Chia kata tutup satu mata, buka satu mata. Correctly. Okay. Okay, student. Do you have any question? Ikmal, Harith tanya. Doktor, ada teori question kan? Itu macam saya cakap tadi, jangan tanya apa masuk periksa. Saya dah cakap dah. Kamu dah kenal saya daripada PSC, sekarang PSA, kamu nak tanya lagi ke apa? Apa yang saya sebut sekarang ni kamu patut understand lah. Puan nak minta discuss soalan 4 final. Hazmi 22-23. Soalan 22-23 tu setakat lah ni saya tak pernah cerita pun. So saya rasa tak ada isu lah, kat situ kamu nak study ikut kamu lah. Nah, boleh? Tengok Haikal Hakimi duk tanya fokus apa? Semua formula dia sediakan. Formula boleh jawab. Formula bagi. Tapi soalan apa tadi? Tanya nak fokus apa? Haikal Hakimi, saya duk cerita dah banyak kali dah. Siapa yang duk my kelas saya rasa dia pun tahu dah apa masuk periksa. Nah, silap. Tertypo. Okey. Jangan susah hati. Itu yang saya nak pesan. Duk tanya ada teori ke dah? Orang dah cakap dah. Tu dia kata. Ni saya sebut ni kan. Apa yang saya sebut ni kalau kamu patut faham dah. Ni revision class. Saya duk ulang. Siapa yang masuk kelas saya kamu patut tahu dah. Saya duk ulang. Doktor nak minta appendix boleh ke? Tak payahlah nak bagi appendix. Saya dah pesan dah. Saya bagi tahu dalam kelas dah. So, yang dalam kuis tu, apa yang saya bagi tahu, yang apa kat depan tu semua masuk. Semua katalah kamu nak guna apa formula tu semua ada dah dalam appendix tu. Yang penting kamu tahu je nak guna formula apa. Nah, nak macam mana guna formula tu. Semua formula yang nak pakai tu semua bagi. Delta Naught, Delta Max, Critical Clearance Angle, TCR semua bagi. Yang penting kamu tahu je macam mana nak guna. Okay? Saya rasa tu je lah kot. Dah banyak dah saya bagi. Tapi lah kata macam tadi Hazmi duk tanya. Nak tengok soalan final year. Yang dulu-dulu tu boleh lah nak tengok. Ikut kamu lah. Nanti saya layan lah. Tak ada masalah. Okay, tapi untuk exam ni, saya rasa dengan tutorial question, walaupun saya discuss ada beberapa soalan je. Kan? Kamu patut boleh nampak dah siapa yang duduk dengan saya lama dalam kelas ni sejak berapa minggu ni. Kamu patut tahu dah saya duk ulang. Ada beberapa benda saya duk ulang. Tak berhenti-berhenti. Tanya Elvin tu. Saya rasa siapa yang masuk kelas saya mesti boleh faham dah apa nak masuk periksa. Sebab saya duk ulang. benda yang sama berulang-ulang kali. Okay. Hazmi kata faham. Alhamdulillah. Okay. So,
Doktor,
ya.
recording ni Doktor share malam ni juga?
Malam ni saya nak record. Tengoklah nanti sekejap lagi kalau saya rajin. Kalau tak esok, lusa ikutlah.
Baik Doktor.
Okay. So, tapi katalah kamu memerlukan bantuan lagi. Apa yang kamu tak faham. Hari saya ready Rabu, Khamis, Jumaat pukul 3 sampai pukul 4. 23 nanti doktor share lah video. Nanti betul 23 tu lepas exam tu nanti saya share lah video ni. Atau mungkin kalau tak apa nak rajin tak share langsung lah. Okay, student. Okay. Nak darab 1/3, 2/3 tu. Allah, itu senang sangat tu. Berapa kali dah duk cerita dalam kelas. Kalau fault tu berlaku dekat sini, kan, kata fault berlaku kat sini, dia mestilah daripada 1/3 ni, daripada line ni, kata dia bagi line ni 0.3 kan. Okay, so ini mestilah 1/3, ini mestilah 2/3, tu je daripada line ni, kata 0.3 line ni kan. Dia bagi X between bus 1 to bus 2 J0.3 for example lah ni kan. So fault berlaku dekat
Doktor, skrin tak nampak.
Okay, so fault katalah kat sini. Line ni bus 1 to bus 2 0.3 kan. So katalah fault saya bagi tahu dekat 1/3 daripada tu. Tapi saya tak bagi susah kat kamu lah macam tu sekali sebenarnya. Saya bagi tahu je fault tu kat mana. So janganlah susah hati. So katalah fault ni bus 1, bus 3 ni 1/3 daripada line ni. So 1/3 J0.3 tu dapatlah J0.1. Yang ni 2/3 kat sini. So 2/3 kali J0.3 dapatlah J0.2. Tak adalah saya nak bagi kamu susah macam tu. Tapi saya bagi tahu dah kat mana fault tu. Kamu patut, saya tak adalah bagi susah kamu kat situ. Cumanya kenapa yang saya cerita kat kamu tu, saya tak maulah kamu ingat fault tu boleh berlaku di tengah-tengah je. Sebab soalan kata, kalau kamu baca nota yang saya tulis dengan tangan saya tu, kan, kamu baca nota tu, kamu mesti boleh faham dah cakap, ini fault dekat sending end. Ini fault dekat, mana tengok. Saya tulis ni nampak ni, some distance away. Nota saya tulis dah kat sini, some distance away from the sending end. So maksudnya can be anywhere. Tak semestinya dekat tengah-tengah. Tu. Itu kenapa saya nak cerita 1/3, 2/3 tu. Okay? Boleh? Ada lagi? Alright. So, jangan susah hati sangat. InsyaAllah kamu boleh buat. Itu yang paling penting. Kalau kamu tak faham, kamu mainlah jumpa saya. 20 minggu depan ni, saya buatlah kelas juga. Bukanlah buat kelas apa pun. Saya tak buat kelas pun. Saya tak buat bilik pun apa-apa. Kalau kamu nak main, kamu main je lah. 17, 18, 19. Sebelum periksa lah Isnin. Nah, cumanya satu je saya nak pesan. Kamu jangan tanya apa nak masuk periksa. Sebab saya dah bagi tahu dah. Okey? Sama ada kamu nak memahami kelas saya tu ke tak. Saya dah bagi nota. Bukan tulis nota slide je. Nota tulis tangan lagi. Soalan tutorial semua duk bagi. Tapi satu saya pesan. Kalau saya jumpa student, waktu final exam nanti, kamu bawa main nota saya tu, meniru final exam, kamu memang kamu tahu lah nasib kamu nanti. Okay? Saya buat benda tu semua supaya mudah kamu nak belajar. Janganlah menggunakan benda yang saya bagi tu, yang supposedly saya bagi tu dengan supaya bantu kamu untuk faham, understand. Supaya janganlah menyusahkan saya. Janganlah menyusahkan saya. Menyusahkan saya, menyusahkan diri sendiri. Nah, okay. So, saya tak ada apa nak cakap dah. Kalau siapa perlukan bantuan, saya saya open lah 3 sampai pukul 4 daripada hari Rabu sampai hari Khamis depan ni kalau nak tanya soalan. Lepas tu, tu soalan kalau ada apa-apa soalan. Kemudian katalah nak tu kalau ada soalan. Lagi apa lagi? Kalau tak tu ada soalan suruh student lah tanya. Student tanya. Apa tu nak tengok soalan-soalan final tu boleh lah nak tengok tapi nanti Rabu lah, Rabu Khamis Jumaat. Okay, Isnin Selasa saya tak ada. Okay student, I think that's all for today. I wish you all the best. InsyaAllah kamu boleh lah buat soalan final exam tu. Saya sebenarnya seriously saya yakin lah kamu boleh buat. Okay student, that's all. Okay, all the best. Assalamualaikum. Semoga semua dapat result yang terbaik lah untuk exam. Okay, Assalamualaikum.
Sedang si doktor.
Jangan
Doktor.
bagi saya ke office esok-esok saya tak ada.
Thank you, doktor.
Ni siapa hasil?